The subject of filters is a very large and potentially complex one. They are some of the most important circuits in all of electronics, and we will return to them later on in more detail. However, at this point, I'd just like to point out that simple RC type circuits of the type we've been studying over the last few videos can form useful filters and are often used in this way. In fact, it's probably the biggest single application of RC circuits within electronics. LR circuits can also be used in just the same way, but inductors are larger, more expensive, and more delicate than capacitors, and are generally not used at lower frequencies. At higher frequencies, for example in radio circuits, LC filters are often used. At such high frequencies, inductors are smaller and more manageable, and such filters have two advantages over RC types. Firstly, because they don't contain a resistor, they don't dissipate energy. And secondly, for reasons which will become apparent later on, they generate less electrical noise, which is a type of interference, than filters which use resistors. I should also mention at this stage that it is possible to make filters out of a variety of other components, one of the most important being quartz crystals. So let's have a look now at low and high pass RC filters. The low pass version is shown in the diagram. In a very simple analysis, at DC and very low frequencies, the capacitor looks like an open circuit. Remember, it has a high reactance at these frequencies, infinite at DC. In contrast, at high frequencies, it looks a bit like a short circuit because it's got a very low reactance and therefore routes all these signals straight to ground. Further insight can be gained by redrawing the circuit. Here we can see that it actually has the same form as a voltage divider. If you don't remember about this circuit, look back to our video about resistors. We can also see from our previous discussion of phase that the phase will vary from the output to the input, and the graphs shown show both the effect of frequency on the amount of signal transferred and frequency on the phase between the input and the output. Because there are large differences in value involved between the pass band where the filter passes the signal and the stop band where it stops it, the graphs are often plotted on a logarithmic scale, not using the actual values but the logarithms of these. If you look back to our video on decibels and units, you'll find out why. We find from this that the frequency at which half the power going in comes out, which is called the 3 dB point, is also the frequency at which the phase shift of the circuit is 45 degrees, and this is given by a simple formula. The frequency is equal to 1 over 2 pi RC. The high-pass filter just works in exactly the opposite way, and the diagram shows the graphs for this. As I mentioned earlier, we will return to the question of filters again later in the course in more detail.